All right, today with Math with Mr. Young, we're going to work on 5.4, the distributive property. Our standard is 6th grade evaluating expressions A, and our objective is that we're going to be able to apply the distributive property to generate equivalent expressions. Our mathematical literacy is distributive property and like terms. All right, for 5.4, our success criteria is that we're going to be able to explain how to apply the distributive property, how to use the distributive property to simplify algebraic expressions, and how to use the distributive property to combine like terms. All right, with our mathematical literacy, I'm talking about mathematical vocabulary words. We have the distributive property and like terms. So we have two today. All right, so let's talk about the distributive property of multiplication. Now this allows us to simplify an expression by taking out the parentheses. So here we have a formula, a times b plus a times c. So a times b plus a times c, that's what that means. And when we distribute, we're going to multiply a times b, and then we're going to distribute a times c, and then add those two terms together. So we have an example down here. We have 2 and times 4 plus 6. Okay, so 2 times 4 plus 6. Okay, so all we're going to do is that we're going to add two numbers inside the parentheses here. So we're going to add two numbers inside the parentheses. But then we're going to multiply that sum by a number outside the parentheses. And that's going to equal to basically first multiplying the number outside the parentheses. And here's what I mean. So 2 times 4, that we're going to distribute 2 times 4, then that plus sign, and then multiply 2 times 6 again, 2 times 6. Okay, so 2 times 4 is 8, 2 times 6 is 12, and then 8 plus 12 is going to be 20. So there you go. Again, we use the distributive property of multiplication by distributing 2 times the first term, which is 4, and then 2 times the second term, 6, and added those two terms together to get 20. All right, next we're going to combine like terms, or let's talk about what terms are first. Now a term is a number by itself, or the product of a number and a variable, or more than one variable. So a term would be like 2a plus 1b plus 7. So a term is always separated by an addition or a subtraction operator sign. Okay, so in this case we have an addition sign there and an addition sign there. So 2a is a term, 1b is a term, and 7 is a term. Again, terms are separated by a subtraction symbol or a addition symbol. Okay, so now when we collect like terms, we're combining like terms, okay, to simplify the expression. What that means is that we're going to rewrite the expression so that it contains fewer numbers, fewer variables, and fewer operations. Basically, you make it look more simple. Here's what I mean. So we have, let's say that we have, I don't know, let's have Ranshaw here. So Ranshaw has 6 apples in her basket. So we're going to call each apple A. So if we count, there's 1, 2, 3, 4, 5, 6 apples in the basket. So this, we express this with A plus A plus A plus A plus A. But it'll look so much simpler if we use A as a base number, or you could do that. Actually, that only works with multiplication, but we're adding here. So this would be, there's 6 apples. So there's 6 apples. So 6 here would be your coefficient, and A would be your variable. So what this means is that we multiply those 6 apples to state that there's 6 of them. Okay, so this is all the same. Okay, so these are all like terms. All right, so what we're going to do next is we're going to combine like terms to have this make sense to you guys, along with using the distributive property of multiplication. All right, so we're going to go ahead and combine some like terms as examples. So we have three different expressions. We have 6a plus 7. We have 9x minus 3x plus 5. And 7m plus 3y minus 2m plus y plus 8. Now, when we talk about like terms, we're talking about terms. Terms are separated by addition and subtraction symbols. So if you have a number here, and a number here, and a number here, these would be terms separated by the addition and subtraction symbols. Okay. Now, when we ask questions about how things are alike, we're talking about how they're the same. Okay. How are they the same? So, if we look at the first expression, 6a plus 7a, these technically would be like terms. So again, they're separated by the addition symbols. So 6a is a term, a is a term, and 7a is a term. They're all like terms. But if you ever see a variable by itself, like a here, just know there's always a 1 there. Okay. So when we combine like terms, 6a plus a is going to be 7a. 7a plus 7a is going to be 14a. So we just simplified the expression by combining like terms. Same thing, we have 9x minus 3x plus 5x. Again, there's 1, 2, 3 terms, okay, because they all have or they're all separated by a subtraction symbol and an addition symbol, so 3 terms. Now here, they all have the same variable x, so they are like terms. They're terms that are alike. Now, according to Gemma, grouping symbols, exponents, multiplication, addition, multiplicative operations, additive operations. So we're going to go from left to right. So we're at the additive operations with subtraction and addition. So 9 minus 3 is going to be 6. So 6x plus 5x is going to be 11x. You just simplified the expression by combining like terms. Okay. The bottom one, you have 7m plus 3y minus 2m plus y plus 8. Again, a variable y is by itself. There's always a 1 by there, so a coefficient 1. So let's look at all the ones that have an m. So 7 m's here and negative 2 m's there. So those are like terms. 3y and 1y are also like terms. So what we're going to do is we're going to combine them. So it is 7m and negative 2m combine. So think of it this way. What is 7m minus 2m? Well, 7m minus 2m is going to be 5m. Okay, and then the 3y and y, 3y plus 1y is going to make 4y. Okay, positive 4y plus 8. Now, there you go. So the simplified expression is going to be 5m plus 4y plus 8. So you have 5m, you still have 3 terms. 5m is a term, 4y is another term, and 8 is another term. But you have 2 variables, 2 different variables. They are m and y. You have coefficients, and again, coefficients, a lot of you guys are getting this wrong because either you're not paying attention or you sign in and leave the room. I don't know, that's on you, but you should pay attention. Coefficients, again, if you look at a variable, the coefficient is the number right by the variable. So a coefficient for 5m is going to be 5 because it's by the variable m. And for y, your coefficient is 4 because it's by the variable y. Now a constant is another term without a variable. It's just a number by itself that's separated by an addition or subtraction symbol. So we have that one constant. Again, there is 3 terms. 5m is a term, 4y is a term, and 8 is a term because they are separated by the addition symbols. Okay? Alright, so we're going to use models to simplify expressions. Now, When we talk about models, we're talking about using diagrams, we're using pictures, that kind of stuff. That's what we mean by modeling. So we're going to model the expression. Now, we have three different expressions here. Now, the first one up top, you have from here to here is going to be x plus 4. We don't know the value for x, for the length. But what we do know is that from here to here is 4, but we don't know what the x value is right here. We do know that the height is going to be 3 though. So for this expression, what we're going to have to do is that x plus 4, we're going to have to multiply that by 3. And then how we simplify this, you're going to use the distributive property. So you have two terms inside the parentheses. You have x and 4 separated by the addition symbol. Now we're going to use the distributive property of multiplication by multiplying 3 times x, and then multiplying 3 times 4. So plus 3 times 4. So 3 times x is going to be 3x, plus 3 times 4 is going to be 4, 8, 12. So your simplified expression is going to be 3x plus 12. Okay. Now, as we move forward, we're kind of going a little step further, and that's fine. So here we're going to, again, we have from here to here is going to be 6. From there to there is going to be y. We don't know what the y value is, but we do know that this is 6. So this is going to be 6 plus y, so 6 plus y, and we're going to multiply that by 8. So again, using the distributive property, 8 times 6 plus 8 times y. Okay. 8 times 6 is going to be 48. Plus 8y. There you go. You simplified the expression. Can't go any more than that because you know, they are unlike terms. They're not like terms. So there you go. You simplified the expression using the distributive property multiplication. So down here, you have 1, 2, 3, 4, 5 different n's. Down here you have 1, 2, 3, 4 different n's. So what is 5n plus 4n? They're both, we have two terms. They are like terms because they have the same variable. So 5n plus 4n will be 9n. Okay. You could even go the other way. So 5n minus 4n would be 1n, or just n. All right, so there you go. Simplifying the expressions, combining like terms, and using the distributive property of multiplication. All right, I want to continue with more examples about combining like terms. So we're going to simplify each expression here. So let me write the directions. Simplify each expression. Again, it doesn't tell us to evaluate. We're not solving, but we're just simplifying the expression to where we have fewer numbers, fewer variables, fewer terms, that kind of stuff. Okay, so we're going to combine like terms. So listen and watch if I underline something once or twice. Okay, so we have 3x here. So 3x, what looks the same as 3x? Well, 2x. So we have a 9 here. What looks the same as 9? Well, there's negative 5. Okay, so we're combining like terms. So 3x and 2x are like terms, and 9 and negative 5 are also like terms. So there are 1, 2, 3, 4 terms that are separated by the addition symbols and subtraction symbols. So terms, you got to look at how many terms you have. So we have 4 different terms. The ones with 1 underline under it are like terms. The ones with 2 number lines under it are like terms as well. So check this out. What is 3x plus 2x? Well, that's going to be 5x. Okay. Now we're using the commutative property of addition, by the way. And then what is 9 minus 5? So 9 minus 5 is going to be 4. So that's going to be a positive 4. And there you go, my friends. You just combine like terms. Another way you could do this, what I really mean, and maybe this might help you guys out. Well, when we combine like terms, it's 3x plus 2x, like I mentioned, plus positive 9 minus 5. So when we do this, what we're really doing is, since there's an x there, 3 plus 2, okay, so 3 plus 2 is 5, so this is 5x, and then 9 minus 5 is going to be a positive 4. So that's what we're really doing. So again, we used the commutative property of addition, we distributed, and then we also simplified. That's what we're really doing here, okay? And then we have y plus y plus y. Now, I've already mentioned that anytime you have a variable by itself, there's always a 1 by it. So they're not necessarily by itself. They have a coefficient of 1 by them. So you have 1, 2, 3 different terms that are separated by those addition signs. So here, what this means is that we have 1y plus 1y plus 1y. And if we use the distributive property, you have 1 plus 1 plus 1. And then y on the outside, this is going to be 3y. Okay. So in other words, 1y plus 1y plus 1y is going to be 3y. All right, so there you go. Let's move on to the other numbers. All right, for the next problem, we're going to use the distributive property. So what I mean by that is we're going to rewrite 7z. Okay, so 7z. And then we're going to add, so when we distribute 2z, this is going to be 2z. And then 2 times 5y, so this is going to be minus 2 times 5y. Okay. Now when we simplify this, since 7z is by itself, this is just going to be 7z plus 2z minus 2 times negative 2 times 5y is going to be negative 10y. Now when we combine like terms here, 7z plus 2z, because they're like terms, it's going to be 9z minus 10y. So this is a z. There you go. You just combine like terms. Now for the last one, 3x plus 10. Again, you're going to distribute 3 times x. So that's going to be 3x plus 3 times positive 10 is going to be 30. Can't simplify any more than that. And there you go. You just combine like terms. Just remember that in this algebraic expression, all the ones that we did, like terms are the terms that have the same variables that are raised to the same exponents. So look at the constant terms as well, because they're also like terms. All right, lastly, we're going to model real life here. So we have a word problem here. So we have Jose. Jose is X years old. We don't know how old Jose is. So Jose is X years old. His brother Felipe is 2 years older than Jose. Their aunt Maria is 3 times as old as Felipe. We're going to write and simplify an expression that represents Maria's age in years. Let's see here. Things that we do know. We do know that Jose, we do know that he is, there's an X amount of years that he's old. So the expression is going to be X. There's Felipe. We do know that he is 2 years older than Jose, sorry. He is 2 years older than Jose. So that expression would be X plus 2, because he's 2 years older than Jose. And then we have Maria. She is 3 times, so Maria is 3 times as old as Felipe. 3 times as old as Felipe. So basically we multiply 3 and x plus 2. So this is going to be 3 and x plus 2. Alright, so we're going to look at this expression. So we're going to simplify the expression that represents Maria's age in years. So we're going to simplify the expression. I don't know if you guys heard of that, but there's a bus driving around dropping off food that represents Maria's age. So Maria's age is going to be, she's 3 times as old as Felipe, and Felipe is 2 years older than Jose. So there you go. There's the expression we wrote. Now we're going to simplify it. So what this means is we're going to multiply and distribute 3 times x. So this is going to be 3 times x. And then plus, to put this addition symbol there, plus 3 times 2. So 3 times 2. So now we use a distributive property multiplication there. Now we're going to multiply. 3 times x is going to be 3x. And then 3 times 2 is 6. So there we go, my friends. After we multiplied, the simplified expression is 3x plus 6. So Maria's age in years is represented in this expression, 3x plus 6. So there you go. Hope you guys learned a thing or two about like terms and using the distributive property of multiplication. By now, you should be able to explain how to apply the distributive property. You should also be able to use the distributive property to simplify algebraic expressions, and also to use the distributive property to combine like terms. Alright, that's all we have today, so please pay attention, attend classes, find a motivation to get your work in. Remember, we all want good credit scores, so it starts with good habits, developing good habits. And again, think of your assignments as bills that you have to pay on time to boost your credit score. Okay, all right, we'll see you guys in a bit.